Hi, learners. I hope you are doing well. Today, we are going to talk about differential calculus. But as you are already aware, we've done a few lessons previously, and we are going to move on to look at what tangents are all about. So if you are ready, let's set the ball rolling. So we're going to talk about a tangent to a curve. The objective of today's lesson is simple. By the end of the lesson, you will be able to identify tangent to a curve, draw a relationship between tangent and curve, and solve problems based on them. Now, you already know that we've done something about rules of differentiation, first principles. So this is the time that we have to talk much about tangent, especially the equation of a tangent. Now, so let's see what we can do here. Tangent is a straight line or plane that touches a curve or curved surface at a point, but if extended, does not cross it at that point. Now, look at the picture here. As you can see, we have a tangent. It is a straight line here, and then there is a curve here. Now, the tangent and the curve meet at this red point here. So you need to take note that when a tangent and a curve meet, they meet at a point of contact. Now, let's look at this circle here. It meets the tangent at this point here, this red point here. So that is what we call the point of contact. There is a reason why I'm focusing and emphasizing on that point. You will realize it in the next step. Here is another tangent, and here is the curve. So as you look at all these curves here and the tangents that touch them, you realize that the tangents touch them at only one point. There is no way that a tangent will cut across the graph. If the tangent cuts across the graph, then it is no longer a tangent. It means it is an ordinary line. So you need to take note of that. What have I said? You must remember that a tangent only touches a curved surface or a curve at only one point. Now, at a given point on a curve, the gradient of the curve is equal to the gradient of the tangent to the curve. The derivative or gradient function, which is also called like that, describes the tangent of a curve at any point on the curve. Similarly, it also describes the gradient of a tangent to a curve at any point on the curve. To determine the equation of a tangent to a curve, you need to look at the following steps. First, find the derivative using the rules of differentiation. Substitute the x-coordinate of the given point into the derivative to calculate the gradient of the tangent. This step is telling you that the x value they are talking about, or the x-coordinate that they are talking about, is at the point of contact. Remember, I told you there is a point where the tangent and the curve meet. That is a point of contact. So the x value of the point of contact is what you have to substitute into the first derivative, and the result becomes gradient. Now, substitute the gradient of the tangent and the coordinates of the given point into an appropriate form of the straight line equation. Now, make y the subject of the formula. So that is very important. So when you are working, you must always focus on making y the subject of the formula. Now, we come to another step. Look at this example. Determine the equation of the tangent to the graph of y is equal to 2x squared minus 3x plus 1. This equation here is the equation of a curve. Now, so this curve here must meet the tangent at a point. Now, so let's look at what we're going to do. Remember, we said in the previous lesson that the first derivative is equal to the gradient of the tangent. That is what I've written here. F prime of x, which is first derivative, is equal to mt. So that is gradient of a tangent. Now, let's look at it. So we take the first derivative of the equation. Now, remember, y can also be written as f of x, you know. If you like, you can write dy over dx. Now, we did the rules of differentiation already, so I'm not going to explain much about it. So the derivative of the equation there can be dy over dx is equal to 4x minus 3, or you can say f prime of x is equal to 4x minus 3. Now, we are looking for the point of contact, because when you have a tangent and a curve and you are not given the point of contact, you have to find it. So as a result, we have to determine the x value of the equation. So we take the original equation and equate it to 0 so that we can look for the x value at the point of contact. You know, factorization. So as we factorize, or you can use the quadratic formula to solve this, you're going to have two x values. X is equal to 1 over 2 or x equal to 1. Now, so if you find the first derivative and you substitute x into the first derivative, the result that you're going to get is called the gradient. But if you take an x value and you substitute it into a normal equation or just f of x, once it is not a derivative, f of x stands for y. So once you substitute an x value into f of x, the result is a y value. But when you substitute x into first derivative, the result is called a gradient. So we take the highest value here. Between half and 1, the highest value is 1. So we substitute it into the derivative, we get the result to be 1. Okay, so it means that the first derivative, where we substitute x, the result is a gradient. Our gradient is 1. The equation of a tangent is y is equal to mx plus c, or f of x is equal to mx plus c. Now, we know the gradient. So instead of writing mx, we will write 1x. Now we have to look for the value of c. So as we take the value of c, how do we look at it? Therefore, we have to take two values. You know, we have x and y coordinates. So we take the x and y coordinates and substitute it into the equation so we can get the value of c. Now, so therefore, when we group like terms or we find the operational inverse of positive 1, the result will be negative 1. Therefore, the equation of the tangent will be y is equal to x minus 1, or f of x is equal to x minus 1. So that is all about that question, determining the equation. Let's move to the next one. It says determine the slope of the tangent to the curve given by y is equal to 3x minus 5 over x squared at the point where x is equal to negative 2. Which point are we referring to here? It is the point of contact. This is where the curve and the tangent meet. So a point is made up of x and y coordinates. So now you are given x coordinate to be negative 2. Then you also have to find the y coordinate. Remember that. Another thing is that once they tell you that these two meet, you must talk about the derivative by all means. But the equation given here, though it is a curve, it is hyperbolic in a way, because the denominator has the square of x. So what we need to do is to convert minus 5 over x squared into a negative exponent before we do that. That is why we have y is equal to 3x minus 5x to the power of negative 2. Now, so straight away we have to find the first derivative. So the first derivative, obviously, as you know, is 3 plus 10x to the power of negative 3. So what do? Now we know that our derivative is 3 plus 10x to the power of negative 3. But the thing is, when we are working, to make it very easy, we have to convert or reverse the negative exponent back into positive exponent before we do that. I said that in our previous lesson during the rules of differentiation. So it becomes 3 plus 10 over x to the power of 3. Now we've got the derivative. So what must we do here? We need to say, okay, if we know the derivative, when we substitute x into the derivative, we'll get the numerical value. Remember, 3 plus 10 over x cubed is a gradient in terms of x because there is still x there. So now we have to substitute the x value of the point of contact into it so that we can get a result, which is now the numerical value of the gradient. Now we have 7 over 4 as the result. You can break it into decimals, and then here is your solution. So again, always remember one thing, that you cannot be working with equation of a tangent without first looking at derivative. Now, so let's look at this question. The equation of one of the tangents to the graph of y is equal to 3x minus 5 over x squared is given by 7x minus 4y is equal to 62. Find the x coordinates of the point of contact. Now, there are two equations here. The first one has a square of x. It is a curve. The second one has an exponent of 1. It is linear equation. Now, so the linear equation is the tangent here, which meets the curve at a particular point. So 7x minus 4y is equal to 62 is linear, but it is not written in the proper form. Remember, the equation of the straight line is y is equal to mx plus c. So we have to make y the subject. So when you make y the subject of formula, obviously, you're going to have y is equal to 7 over 4x minus 62 over 4. You can also simplify it, 62 over 4. But if you want to leave it like that and continue, that is up to you. Now, in this equation, y is equal to 7 over 4x minus 62 over 4. Basically, it's in form of mx plus c. So what is our m? 7 over 4. So that is why we say dy over dx is equal to 7 over 4. Now we got the gradient, but we are looking for the x coordinate of the point of contact, right? So so let's take the equation of the graph and then find the first derivative, or whichever way. So as you can see, the derivative of y is equal to 3x minus 5 over x squared will basically become 3 plus 10 over x cubed. Remember, we did it in the previous lesson, so we just brought it here. It's a linked question. Then we have the derivative now, the first derivative is equal to the gradient of the tangent. That is just an issue we need to remember. So I brought it to highlight that. Now, we have the gradient of the tangent. So what must we do? There are two gradients of the tangent here. 3 plus 10 over x cubed is the gradient of the tangent in an alphabetical form or in terms of x. Then we also have 7/4, which is the numerical gradient. So both of them are called gradients. Therefore, you equate them. So as you equate them, you are going to have 3 plus 10 over x cubed is equal to 7/4. Then, therefore, it implies that you have 10 over x cubed is equal to 7/4 minus 3. You do your own calculations, and you will realize that we will have 10 over x cubed is equal to negative 5/4. So obviously, you can cross multiply to have negative 5x cubed is equal to 40. Well, what can we do? You can divide both sides of the equation by negative 5 and then find the cubed root. So obviously, the cubed root of negative 8 will give us x is equal to negative 2. Now, so therefore, as we got the value of x, then basically the point of contact, at the point of contact, x will definitely be equal to negative 2. What an interesting question. So we consider this function, which is f of x is equal to x cubed minus 3x squared plus 4. Now, determine the equation of the tangent. Y is equal to mx plus c to the curve at 3:4. Now, the examiner has been so kind to tell you that the tangent is y is equal to mx plus c. I would personally have told you that just determine the equation of the tangent, or not even giving you anything like that. I will just say determine the equation of the tangent, so that you remember that y is equal to mx plus c is the format or the standard that we have to use. Well, 3:4 here is a point. What type of point is that? It is the point at which the graph, the curve, and the tangent meet, the point of contact or contact point. Well, let's see how we work it out. First thing first, find the first derivative of the function. So f prime of x is equal to 3x squared minus 6x. That is the first derivative of the f of x is equal to x cubed minus 3x squared plus 4. Then we indicate that the derivative or the first derivative is equal to the gradient of the tangent. That is what I wrote here as f prime of x is equal to mt. Now, so if you have the derivative, what must you do? Take the x value of the point of contact and substitute into the first derivative. So the x value at the point of contact is 3. So wherever there is x in the first derivative, just put 3. You can see the result is equal to 9. Now, the gradient of the tangent now, therefore, numerically is 9. So, what next? We have the equation as of the tangent as y is equal to mx plus c. We got the m of the equation of the tangent, which is 9. So I'll write y is equal to 9x plus c. What else do we need to find? We need to find c. So how do we find c? You take x and y coordinates of which place. You don't just use any point. Since it is a tangent to a curve, the point that you are going to use must be the point of contact. So 3:4 will be substituted, and x is 3, y is 4. As we do that, the answer is obvious. C is equal to negative 23. And that negative 23 is the y-intercept of the equation. Therefore, we have y is equal to 9x minus 23. This is also another thing you need to look at. Well, we have one more. Let's see. Consider f of x is equal to ax cubed plus bx squared plus cx minus 5. This is the cubic graph or the cubic function. The gradient at any point on f is given by 6x squared minus 24. Find the values of A, B, C. Now, if you look at this function here, it is a cubic graph or a cubic function. If we sketch the graph, it will have two turning points. Now, the gradient at any point of f is given. So the gradient now is given to be 6x squared minus 24. This is the gradient of the graph, okay? At a point, that is when we have gradient of a curve at a point, that is what we call the first derivative. All right, so remember that, very interesting. So we know that first derivative is equal to 6x squared minus 24 because it is a gradient. All right, then what do? We say, well, that is the first gradient we are given, but now the equation says, or the function is f of x equal to ax cubed plus bx squared plus cx minus 5. What do? We find the first derivative of that. Don't be afraid. We are only deriving x in the function there. So what do? We have 3ax squared. You always have to subtract 1 from the power after multiplying the same power by the coefficient of the base. So it is 3ax squared plus 2bx plus c. As for the minus 5, it's a constant. So the derivative of any constant is 0. So the 5 is gone. Okay. Now we move on. So the two derivatives here, the first one, which is f prime of x equal to 6x squared minus 24, and the second one, f prime of x equal to 3ax squared plus 2bx plus c, both of them are called gradients. The first one was given in the equation or in the question. The second one was derived by you. So now, since both of them are called gradients, just equate them. Now, remember something. When you derive a cubic graph, it becomes like a quadratic. It's supposed to be in the form of ax squared plus bx plus c. So if we take a look at the function f prime of x here, the f prime of x here is equal to 6x squared minus 24, but it's supposed to be 6x squared plus something minus 24. So that middle term, like the bx, is not there. It tells you that b is 0. That is why if you look here now, you realize that whilst I was writing the 6x squared minus 24 here, I inserted bx here. Since the bx was not existing, it means there is the value of b is 0. That multiplies x to be 0. So take a look at this. So 3ax squared plus 2bx plus c, it's in form of a quadratic equation, because when you derive a cubic function, what you get is a quadratic equation or a quadratic function. All right, so let's continue. As we take the two equations or the two derivatives and equate them, something is going to happen. You now have to compare the coefficients of these two equations. Can you see that? We have 3a now will be equal to 6, and then 2b will be equal to 0, and then c will be equal to negative 24. Look at it. Just equate the coefficients and you will see how amazing this will be. Remember, this is a very tricky question, guys. You need to take time to go through it properly, because it's going to be hectic if you are not careful. You can't manage it. So I want to say that this is one of the questions you have to practice all the time. So now we have 3a is equal to 6. Then if you solve for a, you would have a is equal to 6 over 3, which is 2. 2b is equal to 0. If you divide both sides by 2, you get b is equal to 0. And obviously, c is equal to negative 24. So, learners, it is very important that at the end of each lesson, you should try and consult your past papers. I know most of you know how to refer to past papers. They are in the books, they are online, they are on Department of Education websites, they are on other websites. Please take a look at some of the past questions and work with them. Now, if you have a problem with some questions that are tricky, you just have to consult your educator to assist with questions that you may struggle to answer. Otherwise, if you need online or offline tuition, please contact Edude Academy. As usual, these are our numbers. The WhatsApp number, it's a line number, but if you save it on your phone, it will show the WhatsApp symbol. It is +27 3171 49146 or +27. This is the call number. It is not a WhatsApp number. The second one I mean. +27 650 35 3166. You can look at it on the screen and you are able to know what to do with it. So, guys, it is very important that you take note of all that we have done and you will enjoy your exams. Thank you very much for listening and watching us.